Hello friends, grab your coffee, grab your cookie, and keep both far away from any plastic cutting saw, because today we are talking about plastic dusts. Yes, the dust from polyurethane, polypropylene, polyethylene, polyvinyl chloride, and every other plastic we cut, grind, saw, shred, sand, or recycle. It may look like harmless fluff, but these polymer dusts are highly combustible, electrically charged, and in some cases, chemically hazardous. My name is Michael Klepik, and for 15 years I have been designing dust collection systems for plastics manufacturing, recycling lines, foam cutting, extrusion trimming, and composite production. Let me show you why plastic dust requires real engineering attention. What plastic dust really is, technical description. Plastic dust is generated during cutting, grinding, sawing, sanding, routing, shredding, pelletizing, regrind, and recycling. Technically, first, particle sizes range from 1 micron to 200 microns. Second, the airborne fraction usually ranges from 1 micron to 20 microns. Third, bulk density ranges from 150 to 600 kilograms per cubic meter, depending on polymer type. Fourth, most polymers accumulate strong static charge when powdered. Fifth, many contain pigments, stabilizers, flame retardants, or plasticizers. Plastic dust is lightweight, highly airborne, and electrically active. Where plastic dust appears in industry. You will find polymer dust in first, trimming, routing, and shaping operations. Second, manufacturing of extruded and molded components. Third, CNC machining of plastic sheets or blocks. Fourth, foam cutting and sanding, especially polyurethane foam. Fifth, recycling plants that shred and grind waste plastics. Sixth, pellet grinding and reprocessing operations. Seventh, composite manufacturing and polymer blending. Wherever plastic is mechanically processed, dust appears. Why plastic dust is dangerous. Plastic dust poses multiple hazards. Combustibility first. Polymer dust ignites easily due to high surface area. Second, it forms dense, explosive dust clouds. Third, static electricity from cutting and grinding easily becomes an ignition source. Health hazards. First, fine polymer dust irritates the respiratory system. Second, polyurethane dust may contain isocyanate residues. Third, polyvinyl chloride dust can release chlorine-containing compounds when overheated. Fourth, pigments and additives introduce additional toxicity. Equipment hazards. First, dust clogs sensors, bearings, and electronics. Second, static charge attracts dust everywhere, increasing contamination. Third, fine particles embed deep into filter media. Plastic dust looks fluffy, but behaves like fuel. Combustibility, NFPA requirements. Most polymer dusts are classified as combustible particulate solids under NFPA 652, NFPA 654, because first, particle sizes are typically well below 500 microns. Second, dust clouds ignite from static discharge or sparks. Third, polymer materials burn with high heat release. Fourth, polyvinyl chloride or polyurethane dusts generate toxic gases when burning. Fifth, dust layers increase secondary explosion risk. Plastic dust is one of the top fire risks in recycling facilities. Behavior of plastic dust in airflow engineering-wise. First, polymer dust is extremely light and remains airborne for long periods. Second, polyethylene and polypropylene dust hold strong static charge. Third, polyurethane foam dust behaves like fibrous fluff and clogs ductwork. Fourth, polyvinyl chloride dust becomes sticky when exposed to mild heat. Fifth, fine particles behave like smoke and penetrate low-quality filters. To control these dusts, I designed duct velocities from 4,000 to 5,000 feet per minute. Filtration equipment that works best for and cartridge collectors, effective for fine airborne polymer dust. First, membrane cartridges capture submicron particles. Second, conductive filter media dissipate static charge. Third, pulse cleaning manages lightweight sticky particles. BagHouse Blizzard used for heavy mechanical dust. First, rugged filter bags handle coarse plastics and foam. Second, large chambers maintain airflow with high dust loading. Third, pre-separators reduce stress on the filter media. Additional requirements: anti-static filter media, fully grounded ductwork, abrasion-resistant elbows. Optional: HEPA, final stage for polyurethane or polyvinyl chloride dust. OSHA and NFPA compliance requirements. Plastic dust falls under OSHA first, general duty clause for combustible dust hazards. Second, exposure limits for polymer additives or fillers. Third, hazard communication and SDS requirements. Fourth, mandatory dust hazard analysis for combustible particulate solids. NFPA first, NFPA 652 for dust fundamentals. Second, NFPA 654 for combustible particulate solids. Third, NFPA 68 for explosion venting. Fourth, NFPA 69 for explosion isolation. Plastic dust is fully recognized as a combustible hazard in industrial environments. Capture hood design for plastic dust. Because polymer dust is light, fluffy, highly airborne, and statically charged, capture must be extremely well engineered. I designed, first, fully enclosed routing and cutting hoods for sheet and block machining. Second, high static extraction arms for trimming and edge finishing. Third, downdraft or side draft tables for sanding and shaping plastic surfaces. Fourth, enclosed hooding for foam cutting lines, especially polyurethane foam. Fifth, multi-point extraction along conveyors and shredders in recycling plants. Sixth, sealed transfer points on grinders, pellet mills, and regrind units. Seventh, negative pressure enclosures for polymer blending or compounding operations. Strong source capture prevents static-driven dust escape. Dust from polyurethane, polypropylene, polyethylene, polyvinyl chloride, and other plastics may look harmless, but it is highly combustible, statically active, respirable, and capable of damaging both equipment and lungs. With proper airflow, anti-static design, high-efficiency filtration, and OSHA and NFPA compliance, plastic dust can be controlled safely and reliably. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, plastic belongs in your product, not floating inside your ductwork. See you in the next video.